Integral of 3x squared, e to the x dx. If you would, think about it. I want you to pick a u, something that's easy to differentiate, and then I want you to pick a dv, something that's easy to integrate. Very good. So 3x squared makes a fantastic u. And what makes a great dv? Yes, e to the x dx. Please do not assume that it's always going to be in order as far as the first part is the u, the second part is the dv. Also remember multiplication is commutative. So even if I had switched these two, you would still say 3x squared is your u. All right, because you can pick it apart as much as you need to. All right, what is the antiderivative, excuse me, what is the derivative of 3x squared? 6x dx. So this is like how we did u substitution. We would say du dx is 6x, right? Well, then if you multiplied both sides by dx, you would solve for du. And integrate on the other side. What is the antiderivative of 1, technically, dv? V equals, what's the antiderivative of e to the x dx? E to the x. Is this getting slightly better? Okay, I'll take slightly. If you would, please set up the integration by parts now. So if you would do the uv minus v to u, integral of v to u. So u, 3x squared, minus the integral of v du. Oh, Mike, yes. This one's awful. Yeah, it is awful. That sucks. Yeah, it does suck. I forgot I had this in my notes. Again, what should I be doing? Reading my notes, yeah. Yeah. Okay. Do you want the good news or the bad news? We get to do integration by parts twice. Why? Because I know we're left with another product here that they both have an x. And I just remembered, typically, depending on the exponent here, is usually how many times you'd have to do integration by parts. Because each time it goes down 1. It's more practice. Yeah. Yeah. Obviously. So now when we do the integration by parts again, this part just carries down. Okay, and for sake of space, I'm going to erase that table and we're going to start all over again. But now we're only looking at that second integral. Excuse me. Oh, it was going so well. Birds were chirping. There's a lady outside with birds were landing on her and she was singing about it. She had like 7 little guys following her. It was really nice. No? Okay, I guess not. So looking at the integral of e to the x times 6x dx, I need a u. 6x. And whatever's left over is your dv, e to the x dx. So notice we're starting to see some patterns here. As said, if you have a natural log, pick that for your u. And if you notice, every time we have an e to the x, we keep picking that for our dv. Okay? The power rules, like how we had the 3x squared and the 6x here, they can technically go either place. It depends on the problem. What is the derivative of 6x? 6dx. Very good. What is the antiderivative of dv? v. Antiderivative of e to the x. E to the x. Please be careful. So this 3x squared e to the x copies down minus, and in parentheses, we have to put the part of the uv minus v du. The parentheses are necessary because we have to distribute a negative through. Okay. So what's our new u? New v, which is actually the old v, minus the integral of v du. I have all that room left over. Well, now notice, even though there's a product there, that's a nice product because there's no x on that 6. All right. Let's distribute that negative through. And what is the antiderivative of 6 e to the x? Yeah. Six e to the x plus c.